One of the crucial policy questions that faces exploration is what is the relative role of government and industry? That is, what are the unique government roles that have to be done only by government, and what are the things that industry can and should be doing? There is a lot of debate as to whether NASA should continue to be a mission-driven organization or should be more simply an R&D organization. The model is often raised that NASA should return to its NACA roots. It's really a longer discussion of history to talk about what NACA meant, but there was a different NACA in the 1920s and 30s than there was in the 50s. And so looking at what NASA can and should be doing to serve the nation really is to raise the question about what sort of intellectual capacities and skills do you want inside the government, and what are you willing to outsource or send outside the government. In my view, there are crucial roles that really only government can perform. DoD has had some very, very tough experience when it sought to rely very heavily on the private sector to make decisions that really only the government could make. NASA has had some more positive success in the case of the commercial cargo program, where it was able to rely on the private sector, albeit at some cost, but was able to see capabilities that were created much more efficiently than maybe NASA could have done itself. This is, however, not to say that all programs are going to be appropriate for sending outside to the private sector, nor does it mean that the government should maintain some sort of entitlement to civil servants and capability inside the government. It does mean thinking about what is it we want NASA to do, what sort of skills does it need in-house to be a proper government steward of public monies, and how it can best efficiently leverage the capabilities of the private sector while still being that government steward. When looking at major systems acquisition programs, one of the key attributes for oversight capability is, do you have people on the government side who have real-world experience with managing and developing programs? The general tendency in the science community, I think, has been very healthy in terms of trying to retain one or more major spacecraft builds inside of a NASA center, so that you have an experienced cadre of people when dealing with industry. Those government people have the actual real-world experience. They have the hands-on tacit knowledge that enables them to provide insightful help, oversight, sometimes corrections to the private sector, and they engage with the private sector on the basis of equality or peer, and not simply as being the world's best COTRs. That you want that tacit knowledge to be in the people and in their own experience. It's not really a question just of knowledge retention, which can be done with videotapes and with and documents and manuals. It's a matter of generating and cultivating people with actual hands-on experience, leading projects, solving projects. You do not grow, for example, a senior military officer by simply sending them to one school. You grow them by developing them over a career. You don't grow a system engineer by merely having them take a certification course. You grow them through an apprenticeship, journeyman, master, and craftsman level experiences over their entire career. The only way you get someone with 30-year equivalent experience is by having 30 years of equivalent experience. So the question for NASA, in terms of having this intellectual capability to be a good steward, is going to be, how does it provide those experiences to its own people? Industry has the same question, by the way. This is not unique to government. But how do you go about training people, not just with classroom work, but with actual experience? In my view, the Ares 1X program was a very impressive program, not because of what it accomplished technically. Taking a solid rocket booster and having it fly vertically was not a major breakthrough in terms of engineering design. It was, however, a major breakthrough in terms of training hundreds of people on an actual flight program with real-world experience and making that program a success. And what came out of that was knowledge that could not have been gained any other way of who actually behaved and performed well in the field and who was not as good as the others. Who were the top engineers who could make the equipment work, and who were the ones who may have been intellectually or academically very qualified, but did not have the same feel for the hardware demonstrated in an actual program. So flight test. Flight test is utterly crucial, in my view, to the technical integrity of NASA, to the intellectual capabilities of NASA. Flight test is where you determine what works on paper versus what works in the real world. Flight test is where bureaucratic arguments, political arguments, various assertions and assumptions that are sometimes made in our environment are put to the test and are found either truthful or wanting. So attention to actual data, the healthy experience that flight test brings to that organization for supporting technical truth, for sorting through the technical talent that you have to see who performs and who doesn't. Those things are things that NASA very, very much needs to have and would be, in my view, lost if NASA became solely an R&D organization or solely a source of contracts or solely a source of paper studies. That is, the soul of the agency lies with flight tests. The admonition, test as you fly, fly as you test, applies not only to projects themselves, it applies to organizations. And so in looking toward the future of exploration, laying out a program of regular flight test, hardware development, some of which is held inside the government to train government people, while at the same time pushing the vast majority of the work out to industry to train and give them experience, is a crucial balancing act necessary for the health of the government and industry partnership as NASA explores in the future.